Hey there, welcome back to a little bit of Math 8. Let me see if I can, there we go, that's better. This is lesson 11, unit 2, lesson 11, where we will be talking about writing equations for lines. Now this is kind of a heavy lesson. There's a lot that we need to start putting together, specifically talking about slope, talking about similarity of triangles, talking about transformations, all of those different things. We're going to take everything that we've talked about so far this year, and we're going to start wrapping it together in one as we talk about writing equations for a line. Now, what you may notice about this diagram, first off, is that we have the x-axis and the y-axis. So we're talking about this is a coordinate plane. This is the graph information that is on our coordinate plane, and we are going to talk about that graphing. Specifically, what we're looking for is this. We need to talk about the length of BE. So I need to know that length right there. And then I need to also figure out what are the coordinates. Excuse me, let me help us out. Drop my highlighter. We want to find out that length, but we also want to figure out what is the ordered pair that goes right here with point E. Now, what we may already recognize right now is that, well, if it's 2 right here, then the x coordinate must also be 2. But the question is, what is y? There's no grid on here to help us to be able to find that, but we're going to find that using similar triangles and work our way through this. So let's go ahead and start by finding the length of segment BE. We need to confirm that these triangles are actually similar. And so what we're going to do first off is we're going to prove this with angle criterion, which says that any two triangles are similar if they have two pairs of corresponding angles that are equal in measure. Clearly, these two triangles, the little triangle versus the great big triangle right here, have a common angle of 90 degrees, but they also share this common vertex of A. When we look at this common vertex of A, we notice that this angle right here of EAB and DAC are in common, so that means that the angle for both triangles must be equal. This gives us angle criterion and enough evidence to prove that these two triangles are similar. By knowing that these two triangles are similar, we can use the principles of similarity to find a scale factor to be able to find the length of this segment. Now, that would only be helpful if we had the length of this segment. But when we look at this segment, we can take a look at the y-coordinates, because the y-coordinates tell us the elevation or the height of our triangle. When we go from 7 to 2, let's actually look at this from the perspective of slope. When we look at slope, we look at from point A to point D. We see that we begin here at this point from 0, 2, and we move to this point at D of 4, 7, and we know that slope is rise over run, and we see that as a change in y over a change in x. There's more directly an equation that we can use, or a formula that we can use for slope. Slope is going to be represented as the variable m in this formula. So our slope is equal to the change in y, which we're going to call y sub 2, minus the change in y, or minus y sub 1, and x sub 2 minus x sub 1. This is what we call the slope formula. Informally, what that means is that we take y minus y and then we divide it by x minus x. Now you might be wondering what these little 2's and 1's are all about. Back in the early 1600s, there was a movement to start changing math to where rather than being written all in word form, we were giving symbols to math. And so these symbols right here help as a classification system. When we see the number 1, we're talking about the first ordered pair that we come to on the graph, and when we're working from left to right, and point A would be that one. Since we're not so worried about E, we can treat point D as the second ordered pair that we come to when we're talking about finding slope comparing between 2 points. What that does for us is that tells us that this ordered pair up here would be the x coordinate, or the second x coordinate, and the second y coordinate, and this one down here would be the first y coordinate and the first x coordinate together as a pair. When I know this and I know what those values are, now I can take these named coordinates and I can substitute their known values. In this case, my slope would be y sub 2 would be 7, and then I would take y sub 1 and subtract 2 from that, and then I would take x sub 2 of 4 and subtract x sub 1 of 0. And this will give me my slope that equals 7 minus 2 is 5, and 4 minus 0 is 4. So I know the slope of my line here is 5/4. We will be using that quite a bit more in this lesson as well as down the road. But for right now, what that's going to help us with is to also verify that if my rise comes up to here and my run comes across to here, the likewise, or the other side of it over here, this is also a rise from here to here, or from 2 to 7, meaning the length of this segment is 5 units long, as we see right here in our rise or our change in y. Now that'll help us right here because we know these triangles are similar. That will help us to use our proportional value to be able to determine our scale factor. I know that using the x coordinates along this horizontal, that we move from this point of 0 on the x to 2 to 4. So we see those in their coordinates here and here and here. That means that this side right here, or this length from here to here, is 2 units from A to B, and then from A to C would be 4 units. Knowing that that's our value, then we can find our scale factor is going to be our longer length, 4 divided by 2, or 2. Or if I decided to go from larger to smaller, it would be 1/2. So either one is fine. In this case, since we have the larger to the smaller, we should recognize that slope as the smaller slope of 1/2. And so I can take my distance right here of DC, cut that length in half to give me 5/2, or 2 5/10. That makes the length of segment BE 2 5/10 units long. Now that will be helpful for us on the next part of this because I'm supposed to come up with the y coordinate. Now to find that y coordinate, we already know x because we came across to the same vertical location right here, 2. But now we have to come up from the x-axis all the way up to here. We know from the x-axis to the bottom of the triangles is 2 units because of this ordered pair right here that told us the y is 2. And then we have to go up 2.5 more units to get to point E, which means we have 2 from the bottom plus 2.5 to the top will give us 4.5 units on that segment of E, from B to E, or more importantly for the ordered pair of E is going to be 2 and 4 5/10. Sorry, kind of stumbling over my words. All right, now how is that going to help us? Well, when we come to another situation, what do we mean by an equation of a line? We're actually talking about a rule, kind of like in a game, that has to be followed in order for these points, or in order to know if points land on a line. These points that are on a line are what we call solutions. Every solution is an ordered pair, an x and a y coordinate. That x and y coordinate will be built into the rule. So we're going to call this equation of a line. We can think of that as a rule that has to be followed. If that x and y coordinate follows the rule and makes the equation true, then it's part of this line. If it makes it false, then it's not a part of this line. So let's start here. Let's start by identifying the ordered pairs, the coordinates of B and D. Remember when we tell somebody about how to find the coordinates of a point, we always start out at the origin. And in this case to B, we're following the x coordinate first. So in this case, we're going to come to the right 4 units. And then we will go to the y coordinate of up 3. When we talk about to the right 4 units, we're talking about positive units on x, and then up are positive units on y. We would do the same thing for D, moving from A over 8 units to the right, or from the origin 8 units to the right, and then up 6 units. Now in this case, what we're after with this is we're using something that's called a proportional relationship. A proportional relationship means, let me write this down, or a proportional relation is a graph that passes through the origin. The reason why I call this line proportional is because we start here at 0, 0, and for every y coordinate, y changes or responds directly to x. So when I talk about y moving over, if x is moving over 4 units, and then y is going to move up 3 units. That's one way to think about it, or change in y. For every 3 units of rise, I must have 4 units of run, and 3 units of rise, 4 units of run, and that pattern continues on forever and ever across that line. The way that we recognize this as a proportional relation, we have a variable k that stands for constant of proportionality. And that constant of proportionality exists only when the line passes through the origin. That constant of proportionality will always be equal to the y coordinate divided by the x coordinate. This will help us to understand that when we have a line that passes through the origin, if that constant of proportionality is equal to this ordered pairs as a fraction, then we have proportionality, and that ordered pair is following the rule that's on this graph. So what we need to look at right here is the question is point 2015 on the line? Well, we need to know our proportional value for this line, and that proportional value is from A to B, rise 3, run 4, or in case right here with B, we see that B is going to follow the rule of y, 3 over 4. We also see that D follows the rule of 6/8, which is 3/4 as well. Since point B and point D both follow those rules, they're on the line. So let's look at a point that's at 20 and 15. And we're going to write this with some mathy language. We're going to say this: since K equals 3/4 and 15 divided by 20, when we look at that as a ratio, y over x equals 3/4. The way that we got that, I took a common factor of 5. 15 divided by 5 is 3. 20 divided by 5 is 4. So since k, the constant rate, is 3/4, and this ratio of 15/20 is equal to 3/4, then 20/15 is on line J because it follows that proportional rate. Let's look at this one, 75 and 100. Well, we know with this one, 75 and 100, we know that we can also simplify that one, reducing by a scale factor of 25. So 75 divided by 25 is 3. 100 divided by 25 is 4. I see that 75 100ths is in line with my proportional value of k equals yx. And so I know this is proportional. I know this is on the line. So I can say since k equals 3/4 and 75 hundredths is equal to 3/4, then 100, the ordered pair 175, is just like the other ones on line J. Let's do this one more time. Let's go ahead and look at 68 90ths. Those are a little bit bigger numbers. I'm just going to start with a factor of 2. 68 divided by 2 is 34. 90 divided by 2 is 45. Simplifying that more, 34 has a factor of 2 again. 2 and 17 would be 34. I know that neither 2 or 17 goes into 45 evenly. More importantly, this decimal value, we know that this one is 75 hundredths. We know that this decimal value right here is actually a little more than 75 hundredths. I think it's like 0.75 repeated. So it's not exactly the same. It's close, but it's not the same. But that means it's not the same slope. So we would say this: since k is equal to 3/4 and 68 90ths is equal to 34 45ths, then 90 and 68 is not on line J, because 68 90ths does not equal 3/4. Since it doesn't follow the rule, then since this point, 90 and 68, does not follow the rule of proportionality of 3/4, then it can't be on that line because it doesn't follow the rule that's there. So anytime that we see an ordered pair under a proportional relation that does not match with the constant of proportionality, then it's not a solution for that line. But if it does match up with it, then it is a solution for that line, meaning that it is located on that line. So suppose you want to know the x and y coordinate of any point, and you want to write a rule for this and test whether that point is on J. What we know about this is if I take the y coordinate divided by the x coordinate, and that's equal to my constant of proportionality 3/4, then I know if this comes out true, if true, then the point is on the line. All right. Looks like my packet's just a little messed up. We're going to go on to 11.3, writing relationships from slope. So let's use a little bit more of this and continue on the same types of pieces. I'm going to do this a little differently. So you have this triangle right here. It says here's two diagrams. Here's the first diagram. Here's the second diagram. And what we're doing with these diagrams is it says complete each diagram so all vertical and horizontal segments have expressions for their lengths. Use what you know about similar triangles to find an equation for the quotient of the vertical and horizontal side lengths of triangle DFE in each diagram. So then we want to be able to figure out how to write an equation that would help us to find these values if this is true. The hard part is we don't actually know what those are, and that'll be okay. What we do need to know is this. Just like in our previous problem, we needed to know the slope or the constant rate. In this case, what we're after, we saw before, y divided by x equals k. So we can look at this and we can recognize rather than k, we're going to be talking about slope. And so we're going to say slope is equal to m. Now, why are we doing that? Well, if you look at this line right here, compared to the previous line, we see this one passes through the origin, and this one does not. Because it does not pass through the origin, we no longer have proportionality. And it's not a proportional relation, it's just a regular linear relationship. In order to make that work with what we're doing here, we have to change the rules just a little bit. And the only way that we can change the rule is we can adjust where that line goes through a translation. By using a translation, we will not change the slope of the line. We will simply adjust the location so that it can work with that proportional relationship or with the slope, basically working with the rule that we used at the very beginning. In this case, this line right here, I want to go with the closest point to the origin, and I want to translate this line, line K, so that it will pass back through the origin and appear, like its image will appear to be a proportional relation, even though technically the line is not. It's going to help us to write an equation for that line. So what we need to recognize here is let's look for the slope of this line. Let's take these two known points right here, point A, which is at 4, 4, and point B, which is at 8, 7. And let's go ahead and find the slope. To find the slope, remember we take the second y and subtract the first y. So we have m is equal to y2 minus y1 divided by x sub 2 minus x sub 1. So the second x is right here. Because we go in order from left to right, we see a first and b. So this is x1, y1, x2, y2. And we'll substitute things in. 7 minus 4 divided by 8 minus 4. And what we get from this as a slope is, again, 3/4, kind of like the other one. But that's important to note that our slope here is 3/4. That means anywhere along this line, our slope is 3/4. And even though this one doesn't rise 3 and run 4, this slope right here is still proportional to 3/4. So if we did know that location right there, we could write a fraction that will equal to 3/4. In fact, that's part of our rule. Our rule states that we have to have a slope or a value that represents the value of the rise here and the run here proportional to 3/4. I think the easiest way to do that is to consider taking one of these points that's closest to the origin, the easiest, most known point, such as D, which is 0, 1, and we are simply going to translate that point back to the origin. By translating that point, we know that all other points on this line will actually translate the exact same way because of rigid motion or rigid transformation. What we need to look at with this is what happens to this y coordinate. Well, we need to go ahead and take this y coordinate and decrease it by one value to get back to 0 by 1 unit. So we can say take your y coordinate and subtract 1, but our x coordinate we don't change anywhere else, so we go ahead and we just leave it as an x. Let's test this to see if our rule holds true. We're going to test this with 3 points. We're going to test with A and B and C. If our rule comes out true, then point A, using 4, 4 for x and y, will equal 3/4. 8, 7 for x and y will equal 3/4. And then right here for C, being 8 and 4, should come out false because C is not on the line, and C shouldn't follow the rule because it's not part of this graph. So when we look at point A with 4, 4, we want to go ahead and substitute those values in. The value of y is 4 minus 1 divided by 4 for x, which we see in fact is pretty easy, 3/4. When we look at B at 8 and 7, we want to substitute our value for y, which is 7. 7 minus 1 divided by x, which is 8, and we see that equals 6/8 or 3/4. So we see that point A follows the rules, B follows the rules, C at 8, 4, when we substitute those values, 4 minus 1 divided by 8 equals 3/8. You'll notice that that is not equal to K. This is not equal to our slope, so this one is not on this line. It is not following the proportional relation or the rule that we have established. So when we talk about finding a rule to describe this line or to describe this slope, then we need to use this rule right here. Remember, translate the line down 1 unit. That's how we got y minus 1. Take the y coordinate, translating down affects only the y coordinate, and we didn't have to translate left and right at all. So this would be, it'd be really kind of silly to write x minus 0. We can just leave it as this. Let's compare this to our next line or our next graph, and we see that this one's a little bit further off. First thing with the slope, we can tell that this slope is a rise of 3 and a run of 4, so we have that same thing. Let's go ahead and use that to our advantage, slope of 3/4. And then let's look at a rule. I find it the easiest to go ahead and go from a known point that is on the graph. We could try and go from here, but the problem is I don't know. It looks like 2.5, but I don't know that to be a fact. So I choose to go from this point where it is fact-based, and I'm going to recognize that I want to take this line or this point and translate down 4 units and left 2 units. Now, how would I write that? Well, the y coordinate is what goes with up and down motion. So down 4 units will be y minus 4, and left would affect x. Going to the left is decreasing 2 units back to the origin, where we still have our constant rate of 3/4. Now again, we should be able to test any points that are on this graph, and those points should come out true if my equation is correct. So let's go ahead and try a couple of them. Let's go ahead and try A, which is at 6, 7. And we see that the y coordinate plugs in right here. 7 minus 4 divided by 6 minus 2, which simplifies to 3/4. Awesome. A is good. B at 10, 10 would be 10 minus 4, 10 minus 2. Hard to mix this one up, which would give us 6/8 or 3/4. This is good. And again, if we look at letter C, which is at 10, 7, we want to go ahead and take 7 minus 4 divided by 10 minus 2, which will give us 3/8. Again, not our correct value. That's not equal to 3/4 or our slope, so C is not a part of it. As you can see, these values right here, we can see the rule that we wrote right here, and if we don't follow that rule, then those points are not on the line. In order to be on the line, we have to follow the rule that we wrote, and that rule is going to tell us that we're translating that line down just a couple of units. So when you look at this, are you ready for more? I'm going to go ahead and skip this one because this lesson's already gotten really long. So go ahead and give it a shot if you want. Just keep in mind that when we talk about this, there is a rule that talks about proportionality when the line passes through the origin. Make sure that we understand that when we pass through the origin, we can take a ratio that says that my constant of proportionality is y divided by x. This is also our slope, and we plug that into our slope. There is one more step that we can take. We're going to work on this as we go. But what we can do with this is we would simply recognize this as y divided by x equals 2. If I multiply by x on this side, it eliminates it from there. And we multiply by here, telling us that our equation actually changes into y equals 2 times x. More of this will come. This would be sufficient for the equation for now or for the rule that's followed. Keep in mind that if we move our line off of this, or if our line does not pass through the origin, then it's no longer proportional, and we have to compensate for that. So go ahead and take a look at the lesson summary, review through it. I hope that you have gathered something from this. Let me know what your questions are, and don't you give up on this hard stuff because you're doing great. Take care.